Hi students. Now we are going to discuss about the short circuit test on transformer. This short circuit test is also called as impedance test. The short circuit test is also called as a impedance test. Last class we discussed about the open circuit test on transformer. In this test, the primary is connected to AC supply through the variac. In this test, the primary is supplied to AC supply through the variac. And next one, ammeter and the voltmeter. Ammeter and voltmeter. See that. And next one, the secondary is short circuited. Which side is short circuited? Secondary side is short circuited. How the secondary side is short circuited? With the help of the copper wire. The help of the copper wire. The secondary side is short circuited. Okay. Why we are short circuiting on the secondary side is nothing but see that here, see that here in short circuit test. So this is the transformer. It has a two windings, primary winding and secondary winding. So in short circuit test, primary winding is a high voltage winding. Primary winding is a high voltage winding, and secondary winding is a low voltage winding. Secondary winding is a low voltage winding. See that there is a inversely relation. There is a relationship between the voltage and current for the transformers are both are inversely proportional. V1 by V2 is equal to I2 by I1. So what is the relation between the V1 and I1? Both are inversely proportional. Both are inversely proportional. When this low voltage side is short circuited, it drags the high amount of current from the supply. High amount of current from the supply mains with reduced voltage, not the high voltage. So that's why it is convenient to connect high voltage side to the supply and shorting the low voltage side. Which winding is connected to supply? High voltage side is connected to supply. Which winding is short circuiting here? Low voltage side is short circuit. By doing these short circuit tests, we are measuring the one kind of losses. What is that losses? The losses which we are measured with the help of the short circuit test is nothing but copper losses. Which losses, ma? Copper losses. And next one, so in open circuit test, we are applying the rated voltage. We apply the rated voltage. But in short circuit test, we does not apply the rated voltage to the primary side. Why? Because so with less voltage, okay, the more amount of current. So that's why we are applying the low voltage or reduced voltage on the primary. So for example, our rated voltage is 220 volts of the primary winding. The reduced voltage is we are giving the 10%. 10% is nothing but how much the 10% in 222 volts, 22 volts. We are giving the supply voltage on the primary side is the how much volts here? 220 volts. So these 22 volts is sufficient to transfer the rated current of the transformer in the secondary winding. To carry the rated current of the transformer in the secondary winding. Here, three measuring parameters are there: voltmeter, ammeter, and wattmeter. So, with the help of voltmeter, we measure the voltage. With the help of wattmeter, we measure the rated full load current or short circuit current. Rated full load current or short circuit current. With the help of wattmeter, we measure the which losses, ma? Copper losses. We measure the which losses? Copper losses. Here also, by these tests, we are determining the equivalent circuit parameters. Equivalent circuit parameters of the transformers. What are those equivalent circuit parameters of the transformer? R1E, X1E, Z1, R2E, X2E, Z2E. So like that, these equivalent circuit parameters are calculated. And let's coming to a point here. Next slide. See that here in this. So in this short circuit test, see that here. So in this short circuit test, which one is short circuited? Secondary side is short circuited. When secondary side is short circuited, resistance is very small. Resistance is very small. On rated voltage, it may draw very large current. It may draw very large current. So here secondary is short circuited. When the circuit is short circuited, the resistance is zero. When the resistance is zero, the circuit carries the high amount of current. Why? Because there is no opposition. So that's why for here on rated voltage, if you given the 220 volts, it drags the very large amount of current. So that amount of current is damage the transformer. So that's why that such large current causing the overheating and burning of the transformer. Burning of the transformer. To limit this, here short circuit current to limit this short circuit current, primary is supplied with the which voltage ma? Reduced voltage or low voltage. Reduced voltage or low voltage, which is just enough to supply the rated current to flow through the primary. To flow through the primary. So that can be measured with the help of the ammeter. That can be measured with the help of the ammeter. And next one, the voltage, low voltage can be adjusted. How the voltage we are setting the 22 volts, that can be with the help of variac. With the help of variac, we are setting the value of 22 volts. So short circuit test is also called as low voltage test, reduced voltage test. It has a three names. Short circuit test is also called as impedance test, low voltage test, reduced voltage test. And next one, the wattmeter. Wattmeter reading as well as ammeter reading, voltmeter readings we are going to record it. So what is the observation table of the short circuit test? VSC, ISC, WS. In short circuit test, we are maintaining the rated current. We are maintaining the rated current by applying the reduced voltage, and we are measuring the short circuit power in wattmeter. Short circuit power in wattmeter. Next, see that. So now, when current flows through the windings or rated current, hence the total copper losses is the full load copper loss. Here, which current is flowing in the transformer? Rated short circuit current or rated full load current. So when rated full load current is flowing through the transformer, here it measures the which losses? Full load copper losses are measured. See that wattmeter measures the which losses? Copper loss. See that here? Wattmeter. So that is WSC is the wattmeter. WSC is equal to it measures the which losses now? Full load copper losses. Full load copper losses. You know that. So I1 square R1. It is the copper loss of the which side? Primary side. Plus I2 square R2. I2 square R2. It is the copper loss of the which side? Secondary side. Which side? Secondary side. So what is the total losses? Copper loss when referred to primary side is nothing but I1 square R1E. I1 square R1E. It is the total copper loss of the transformer referred to primary side. And next one I2 square R2E. It is the total copper loss of the transformer referred to secondary side. So this is the expression of short circuit power. WSC is equal to VSC ISC cos phi SC. We know the value of VSC ISC, which is the unknown value here. Cos phi SC is the unknown value. We are finding the cos phi SC. Okay. Next, we are going to finding the equivalent circuit parameters of the transformer referred to primary R1E, X1E, Z1E. How we find them? See that here WSC. What is WSC? Wattmeter, which is used in the wattmeter reading of the short circuit test. So this wattmeter measures the which losses? Copper losses. Which losses? Copper loss. What is the general formula of copper loss? I square R. I square R. Here I is nothing but which current? Short circuit current. That's why in the place of I, we recognize ISC square. And resistance R. R is, we are referring to primary side, R1E, ISC square, R1E. And see that, we know that WSC from the tabular, we know that ISC from the tabular column, which is the known value R1E. R1E is equal to WSC by ISC square. R1E is equal to WSC by ISC square. And next one, so short circuit test is also called as impedance test. How it is called as impedance test? Z is equal to V by I. Z is equal to V by I. So V is nothing but short circuit voltage. I is nothing but short circuit current. Z is equal to VSC by ISC. See that here? Z is equal to VSC by ISC. Z1E is equal to VSC by IS. Z1 is equal to VSC by ISC. So you know that Z is equal to R plus JX అయితే Z1E is equal to R1E plus JX1E. R1E plus JX1E. R1E plus JX1E. Z1E is equal to. We know the value of R1E. We know the value of Z1E, which is the unknown value X1E. Now X1E is equal to root of Z1E square minus of R1E square. Z1E square minus of R1E square. So with this short circuit test, we are finding the equivalent circuit parameters and the copper losses. Equivalent circuit parameters and the copper losses. See that here? See that here? So thus we get the equivalent circuit parameters. What are the equivalent circuit parameters? R1E, X1E. So knowing the transformation ratio, if we know the transformation ratio, we are transferring to the secondary side. Now R1E find out just the R2E is equal to R2E is equal to K square. Okay, K square into R1E. So like that. See that? So after finding, so we are transferring, if you know the value of K, we are transferring to the secondary side, R2E, Z2E and X2E. And next one, R1E, Z1E and X1E, refer to primary side, refer to primary side. So this is about the short circuit test. So by doing the short circuit test, we measure the which losses? Copper losses. What is the other name of short circuit test? The other name of short circuit test is the impedance test or low voltage test. Tests are low voltage tests or reduced test. These are the other names of the transformer. Short circuit test. And next, come to next slide. So here we are finding the efficiency of the transformer by open circuit test. Why we are studying about the open circuit test and short circuit test? These are the indirect method of testing of transformer. From this test, we are finding the values of R naught, X naught, I naught, IC and IM. IC and IM. Next from short circuit test R1E, X1E, Z1E, cos pi SC. So what is the general efficiency of the transformer under full load condition? V2, I2, V2, I2 cos pi. So this I2 is the full load condition కాబట్టి I2F column. Okay. Thus, for any power factor, if the transformer power factor is cos pi, it is any value, either 0.8 power factor lagging, 0.8 power factor leading, 0.6 power factor lagging, like that, we are going to predetermine the efficiency of the transformer. So next, coming to the point of, so efficiency at any load condition. So last class we discussed in efficiency, fraction of load. N is nothing but the fraction of the load, actual load by full load condition. N into volt ampere rating into cos pi. And next one is the W naught plus N square WC. Next N. What is N? Fraction of full load. What is N? Fraction of full load. This is the expression of efficiency at fractional load condition. Fractional load condition where N is equal to various load condition, half load condition, 3 by 4 load condition, quarter load condition. Full load condition is nothing but N is equal to 1. Full load condition is nothing but N is equal to 1. So calculation of regulation. How we find out the regulation here? You know that we already derived the expression of regulation in previous classes. So what is the formula of voltage regulation? I2 R2E cos phi plus or minus I2 X2E sin phi divided by V2 into 100. Effort to secondary side. Effort to primary side. I1 R1E cos phi plus or minus I1 X1 is sin phi divided by V1 into 100. Effort to primary side. So these I2 are the load currents. I2, I1 are the load currents or rated currents of the transformer at which condition? Full load condition. I1, I2 are the rated currents for full load regulation of the transformer. I1, I2 at any other load is nothing but any other load. Half load condition or full load condition is nothing but N is equal to 1 by 2 for half load condition. Quarter load condition is N is equal to 1 by 4. Okay, 3 by 4 load condition is N is equal to 3 by 4. So like that, we are predetermining the efficiency of the transformer and regulation of transformer at any load condition at any power factor. We are predetermining the efficiency and regulation of transformer at any load condition or at any power factor without actually loading. Without actually loading. So that is about the predetermined, that is the indirect method of testing of the transformer. So what are the indirect method of testing of transformers are there here? Two tests are there. One is the open circuit test and one is the short circuit test. By doing the open circuit test, with the help of open circuit test, we measure the iron losses. With the help of short circuit test, we measure the copper losses. No load parameters are determined by open circuit test. Copper loss, that is the equivalent circuit parameters, are determined with a short circuit test. If we know the values of these no load parameters and equivalent circuit parameters, then we are easily finding the efficiency and regulation of the transformer. So what is the main objective of this indirect method of testing? We are finding the efficiency and regulation of transformer at any load condition, at any power factor, at any load condition or at any power factor without actually loading. Without actually loading. So that is about the open circuit test and short circuit test of the transformer. Short circuit test of the transformer. So dear students, so here once you have to practice these all equations. Okay, without practicing, you never remember them. Okay, first you have to practice while listening the class. Okay, thanks to all. Thanks to thanks for your cooperation. Thank you.